Hi everyone. I'm going to take you through the rules for counting sig figs. To give you an idea of what a sig fig is, it's a number that is significant because it shows accuracy. The reason it shows accuracy, whereas other numbers don't, is because it comes from a measurement. So let me give you an idea of what I mean. If you go back to the scale in our classroom and you put a piece of copper wire and it tells you the copper wire is 1.52 grams, all of those digits, each number is significant because it came from the measurement on the scale, and it shows accuracy to the hundredths place. Okay, so this number we would say has 3 sig figs, and you're going to notice a lot of times I abbreviate that just SF when I'm writing it out. If the scale said 1.50 grams, that number also has 3 sig figs because of the fact that it was being accurate to the hundredths place again, yet this time it was only a 0. So when we talk about rules with zeros, the 0 that comes at the end of a number, even though you might not have to type it into your calculator if you're doing a calculation with it, 1.5 and 1.50 to a math teacher is the same exact number. But in science, 1.50 is more accurate than the number 1.5 because 1.5 does not have a hundredths place. So it is less accurate or less certain. So we say that this number has 2 sig figs. So for rules with counting sig figs, if you take a look at the sheet that I gave you, if it's a non-zero number, anything from 1 through 9, they all count. So in this example here, 1,234, all of those numbers, none of them are zeros, they're all significant. Zeros that come in the middle of the number, they're sandwiched in, okay? 708, 1,009. All of these zeros have to count because they're in the middle of the number. So that's why it says 708 has 3 sig figs and 10,009 that number has 5 sig figs. Now, rules 3 and 4 is when it gets a little bit tricky. It's zeros that come at the beginning and at the end of a number. At the beginning, your rule is that they never, ever count, ever. So in the number 0.0098, those zeros that come before the 9 are not significant. The 9 and the 8 are. So this number has 2 sig figs. In the number 0.0207, the sandwiched in 0, the 207, that 0 is significant because it's in between 2 other numbers. The 0.0 is not significant up to here, but the 207 is. Oh, it looks like let me erase that. It looks like, all right, so those 3 digits are significant. Now, that 0.02, oops, that's not what I wanted to do. Hold on a second. That 0.0, this 0 right here, 207, there we go. Let me get rid of some of this. I'm just going to rewrite this up here, guys. Give me a second. All right, 0.0207. This 0.0 number, that number we would call a placeholder. It's showing us that it's a small number, okay, that the number is 2/100ths of a gram or a milliliter or whatever the measurement may be. But that 0.0, we need it there to show the size of the number, and we write it, but it is not considered significant when we're counting the digits of the number that are showing us accuracy. Okay, so just remember that 0 at the beginning does not count as a sig fig. These 3 numbers do, and we would say this has 3 sig figs. Okay? All right, going back to number 4. Zeros at the end of a number. 2 rules. If there's a decimal and if there's not a decimal, that's the determination. So in the first example, it says numbers with a decimal, the zeros at the end always count. You could have 7 zeros at the end of a number. If that number has a decimal, they're all going to count. So in the example 35.00, all 4 count. I am being accurate to the hundredths place. Okay, so I know it's a crazy thing. 35 and 35.00, they seem to be the same number, I am sure, in your brain. However, 35.00 is being exact, all right? It's from a measurement, say from a scale or a graduated cylinder, to the hundredths place. In the second example, 0.0460. It says it had 3 sig figs. So the question is, which of those 3 numbers, there's 5 of them there, 0.0460, which are the 3 sig fig numbers? Well, it can't be the beginning zeros. Those are just placeholders. So it's got to be the 4, 6, and the ending 0. That ending 0 counts because there was a decimal in that number. All right, last rule. It's a pretty easy rule. If there's no decimal, the 0 doesn't count. Again, this 0 is acting like a placeholder as well. So let me explain what I mean by this. Let me get rid of what's on the screen over here real quickly, sorry. 120 is the number. I don't know why this keeps happening to me. Sorry, guys. 120 is our number. I need a pen. There we go. I may have rounded from, say, 122, and I'm just rounding, and I'm saying I got about 120 grams of something. So this 0 is not showing accuracy because there is no decimal. So this number, we would say, would have 2 sig figs. Okay? Now, the number 120, if I wanted to make that 0 significant and count and be accurate, I would have to write 120 decimal point, which seems kind of strange. All right, we don't normally write numbers in that sense where we write 120 decimal. We usually write 120.0. So both numbers would be fine and acceptable. However, if you could only write 3 sig figs, this is the one that you would have to use, the 120 point. If your answer could have 4 sig figs, then you could use 120.0. You're just being one more place of accuracy. So hopefully that helps in terms of figuring out these 0 rules. Let's try some of the practice at the bottom. The first practice is 400 Okay, let's try some of the practice at the bottom of the first page. Number 1, okay, sorry about that, you guys. Let's try some of the practice. The first one is 430. There is no decimal there, so that end 0 cannot count, and I would say that this number has 2 sig figs. Number 2, 0.043. Notice I didn't even write the beginning 0, the first 0, 0.0. That 0 is not necessary to even write, let alone count as a significant figure. So in this number, there is a decimal, but beginning zeros never ever count. So this particular number also has 2 sig figs, the 4 and the 3. Number 3, 4,030. Think about what your answer would be. There's no decimal, but there's also a middle 0. So this 0 does count, and this 0 does not, giving us 3 sig figs. Hopefully you got that one right. Number 4, 40.30. There's a decimal there. So with a decimal, every 0 counts. So we've got 4 sig figs. Number 5, 403,000. Now, no decimals. These 3 zeros we would call placeholders. They're showing the size of the number. It's a really big number, 403,000. It could have been rounded. We don't know if those are exact zeros, so they are not sig figs. We count just the first 3 as significant. The answer is 3. Number 6, 00403. Again, beginning zeros never, ever, ever count. Count the last 3. There's your answer. Are we catching on here? Let's do the last 2. Number 7, 0.430. Okay, I didn't even write that other 0. It's not significant. However, this has a decimal and a 0 at the end. So, zeros at the end, when there's a decimal, always count. Answer's 3. And then the last one there, number 8, is 4,304. This is a good one. It doesn't end in a 0, it doesn't start in a 0, so they all count. The answer would be 4 significant figures. All right, let's jump to rounding, and then you guys can do some practice on your own. At the bottom there, they want you to round the numbers to have 3 Sig Figs. So let me show you how to do the first one. The number they give you is 65,712. So here's the idea. Let me switch my color out for a second. I can only keep 3 Sig Figs. So there we go. 6, 5, and 7 I know are going to stay. But I need the number that I write down to be as large to show the same amount or value of the number as the number that's given. So if I were to just write 657, that's 657. That is a much smaller number than 65,712. So this is when I'm going to add in placeholder zeros. I can't keep the 12 at the end, but I can keep 2 zeros. Now I'm keeping the number the same size. All right, now is a 65,000 value number and not 600. But yet I still only have 3 Sig Figs right there, and these last 2 zeros would be considered placeholders. So you can add placeholders in that don't count as significant, but still give your number the same value as the original. Does that make sense? Let's try number 2. Number 2 is 5,492. Again, round to 3 Sig Figs, so I'm going to stop at the 9. 5,400. The 2 next to the 9 does not bump up the 9, so I'm just going to put a 0. 5,490. Those 3 count, and then that's your placeholder. Let's try number 3. Number 3 is kind of tricky business, so take a look at this. 35.98. All right, the 9 is the 3rd digit. So I have an 8 next to the 9, which is going to round up the 9 to a 0, which means the 5 turns into a 6, and now my answer is 36.0. That's perfect because it has 3 Sig Figs. That 0 counts because of the decimal that's there. Okay, so that one does work to be 3 Sig Figs. Let's keep going. Now there's a beginning 0. 0.03944. This is number 4 at the bottom. All right, what do we know about beginning zeros? Yes, they do not count. It's a placeholder, so leave it there. Okay? Now I'm going to count 3 digits that are significant. 3, 9, 4. Now, I look to the next 4. Okay, this guy. Oops, sorry guys. This 4 does not round up the other 4. It's not a 5 or higher. So I'm literally just going to get rid of it. And my answer is going to be 0.0394. That number, the first 0 doesn't count, and these 3 are significant. All right, number 5, same idea, 0.004235. The first 2 zeros don't count. I keep them there though because they're placeholders. So then I count out 1, 2, 3 Sig Figs, and I look at the 5. Now I've got a 5, so it's going to bump up my 3 and make it a 4. So I'm going to keep the first 2 zeros. 4, 2, 4 is my rounded answer. These are my Sig Figs, and the zeros are my placeholders. Are we catching on, you guys? Last one, number 6. This is one of my favorites. 239.75. All right. I'm going to keep 3 digits to be significant. So it's got to be the 239, and the 75 is gone. However, the 0.7 is higher than 5, so it rounds that 9 up to a 10, which is going to make the number 240. Which maybe right off the bat you're like, oh yeah, that's fine, 240, there's 3 numbers there. There are 3 numbers, but there are not 3 sig figs in the number 240 because that 0 is not being considered significant at the moment because there's no decimal. So if I want that 0 to count, okay, so you see what I'm saying? This one has 2 sig figs at the moment. If I want that 0 to count, I have to put a decimal after 240, like so. And now that answer is 3 sig figs, and that would be your final answer. Okay? Real quick, don't go 240.0. That would not be right. Can you see why? That has 4 sig figs. And that's too many in this case because they were telling you to round to 3. So 240 point is the answer. Now I know that's weird, okay? It's kind of out of the ordinary from what you normally see with numbers. But from here on out, if I write a number that's 240 point, I'm purposely making it have 3 sig figs for a reason, okay? All right, last thing I want to go over is calculations. So flip to that next page. The idea here, and this is obviously where we're going to use sig figs, is when we start calculating. So if you're doing any sort of multiplication or division problem, this is when you're going to use the concept of rounding to certain numbers of sig figs. In the example, okay, they give you 5.2 times 6.489. Now, the answer, when you plug that into your calculator, you get all kinds of numbers after that decimal point. Okay, 33.7428 should be the answer that you get when you plug it in. There will never be a question where you have to ask me or someone else, how many digits should I round to? How many numbers should I keep after the decimal point? In science, you will always know how many numbers to keep in your answer, and it's because of the significant figure concept. 5.2, if that came from a measurement, that measurement was certain to 2 sig figs. Sorry guys, I don't know what this is all about. Sorry, there we go. 2 sig figs. The next number, 6.489, is being certain to 4 sig figs. The rule about calculations is you can only be as certain as your least certain number of your measurement number, I should say. Okay, so this 2 sig fig number is what you're going to keep for your answer. So really, you're looking for the lowest number of sig figs, and that's your answer. The lowest number of sig figs, or lowest amount of sig figs. Okay? So let's do a couple of the practice ones together. In number 1, 189.26. Okay? That has 5 sig figs. 4.41 has 3 sig figs. Which one's lower? Yeah, the 3. So my answer for number 1 has to have 3 sig figs. Alright, so I'm going to plug this in real quickly. 189.26 times 4.41, and you get in your calculator 834.6366. Well, obviously, you are not writing all those numbers down. Okay, not anymore. You know that you're going to keep 3 of them. So, 834, except you got to check and see if you need to round, and yep, 0.6 means we're going to make that 835. Final answer. Rounding to the lowest number of sig figs in the problem. Make sense? Let's try the next 2. 45.0. How many sig figs, you guys? Did you say it? 3 is what you should have said. Times 3.2. How many sig figs? Sorry. 2. Good. How many can you keep in your final answer? the lower one, so 2 is what you're looking for. Now, this one's interesting because when you plug this in, you get 144. That has 3 sig figs. That's too certain. I have to keep an answer that is a little bit less certain with only 2 significant figures. So, you could keep 14, but that number is a smaller number than 144. So what do you need? I hope you said it. You add a 0. That 0 is a placeholder. I still have 2 sig figs. The 1 and the 4 are significant. Oops. And the 0 is kept as a placeholder. So your answer is 140. All right, number 3. 4,093.7 is being divided by 220. Okay? This first number, 5 sig figs. 220. Does it have 3 or 2? I hope you said 2. That 0 is a placeholder. There is no decimal in that number. That is why it has 2. So you get an answer of 18.6077 blah 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 blah. It doesn't matter because you can only keep 2. You can't keep 5. You can't keep 4 or 3. You can only keep 2. So 18, nope. Make sure you look at the 0.6. That rounds to 19 is your answer for 2 sig figs. All right, I hope you're getting the hang of this. One more, and then you can try some on your own. 30.54 is going to be divided by 4.31. 30.54, that's a 4 sig fig number. 4.31 is a 3 sig fig number. Your answer has to be the lowest one of those amount of sig figs, so your answer is going to be 3 sig figs when you round. In your calculator, you should have gotten a number, 7.0858. I know that I can only keep 3 of those digits, so 7.08. However, I look and see that I have a 5. That's going to round it to 7.09. Final answer, 3 sig figs. So try that next sheet on your own and have that for class on Monday or Tuesday. Good luck with sig figs, guys.